Hi guys, in the last video we spoke about distributed database and what are the reasons for even choosing a distributed database, right? There are three main reasons for going with for a distributed database. One is fault tolerance or high availability. Second one is latency, and the third reason is to handle high read volume or to scale to a higher load. So those are the three reasons why you choose a distributed database. And we spoke about replication and sharding. So replication is like copying the entire set of data on multiple machines. Now, let's say this is a server machine 1 and this is a machine 2 and this is a machine 3. So you have some 1 to 100 records here. 1 to 10, let's suppose 1 to 10. And even this machine also will have 1 to 10 and this machine as well will have 1 to 10. So copying the entire data set on multiple machines is called replication. Whereas sharding is a different thing. Like here on one mission I can have 1 to 5. On second mission I can have 5 to 7. Sharding is like you split the data across multiple missions. So this video or coming few videos are mainly related to the replication. We will discuss about sharding later. So this is a replication, you understood, right? And the agenda of this video is first we'll understand about the replication, the introduction, and then differences between a replication and sharding, and what are the leaders and followers in a distributed database, synchronous versus asynchronous replication, setting up new followers, and handling node outages. So coming to the introduction, so replication is nothing but copying the same set of data on multiple machines. Now, like, is it so easy to copy the data? Like, if it is a static data, if the data is not changing, okay, like this is not there, like 1 to 5, 5 to 7 is not there, like if the data is not changing, if your database always have these 1 to 10 records, it's so easy to replicate your data. Like you can put 1 to 10 records, take a copy of that and can copy on as many missions as you want. But if the data is changing, like if data is continuously evolving, how can you copy data from on several missions? Like you keep getting requests and you keep, and how do you know copy this data onto the several missions? It's so difficult to tackle that. So there are several ways or the several algorithms that will help you to replicate data on several on multiple missions. So there are three popular algorithms where data is replicated across several missions. So these are the replication algorithms, like single leader, multi-leader, and the leaderless replication. So when I talk about leaders and followers in the coming slide, you will understand these replication algorithms. So to replicate data, we can use the either of these three algorithms to replicate it. And this is not a new topic. Like databases have this concept like replication since ages, but like recently they got more popular because of this NoSQL databases. Okay, now as we already discussed the difference between replication and sharding, because replication is copying the entire set of data, whereas sharding is you split the data across multiple missions. Okay, so these are the popular algorithms. Like how replication happens is, so like let's say I'm a user. Let us take a Facebook application, okay? Like I have name, date, name, DOB, every name, date of birth, like multiple fields, okay? Now, let's say I want to change my place. Before I used to reside in some place, now I shifted to some other place. What happens? Now all these three missions have initial set of data. Initially I was in US, okay? Now I'm moving to Canada. Now these three missions have my place as US. Now how to update to Canada? Okay, so if you have 100 missions, you cannot ask 100 missions to update your data to Canada, right? You cannot do that. You cannot make requests to 100 missions. You don't even know how many missions exist in Facebook or any other system. So what happens is, in this kind of system, they will have one mission as a leader, okay? Like let's suppose a mission 1 is a leader and all the other missions are the followers. F represents the follower. You can call as follower or replicas, like, or secondaries or slaves, anything. Okay. So what happens is, since you will put a one mission as a leader and the all other missions as a followers. Now, when a user requests for an update of the data, what happens is write request. All write requests go to leader. Okay. So, like my case, if I want to update, I can only ask leader to update my place. I need not go to these 100 missions that are the replicas and update. What I'll do is I'll just ask the leader to update it. So what will the leader do is either synchronously or asynchronously, followers also eventually will get the data, will get the update. Okay. So my job is to just call the leader and then update the place. And how the followers get the data, it's up to the database or up to the system we use. It's not just database. There are so many, like if you have heard about Kafka, even Kafka has this replication concept. So most of the systems has this replication concept. Okay. Now it's up to the system, how it is following, like how it is replicating data on its followers. It's up to the system. So leader's job is to write the data, and follower's job, and like write request will always go to leader, but read request, it can go to any mission, leader or follower or anything. Okay. Now if you see, this is just an example. Like a user wants to update a picture URL. What it does is it will call the leader replica. Okay. Once the leader, what it has done is the new value it has updated to me new.jpg. Now what it does is it will send some kind of information to the followers saying that you also update it. I have updated my data. You also go and update it. That is when replicas will update it. So if you see here, replicas will start updating it. Now, there are two kinds of replication. Like replication of data is happening on the followers, right? There are two kinds of replication that comes into place here: synchronous and asynchronous. Synchronous means like when you think about this example, like leader updates the data and then it gives to the follower, then you might get a query. You said that leader write request will only go to leader replica, and read request can go to any follower replica, right? Now leader has updated it, leader has sent data to follower, but due to some issue, follower has not updated. And when I request for the user data, my request goes to the follower which has not updated the data. Then I'll get a older value, right? So I'll get a older value. That is the issue. That is definitely an issue that needs to be addressed. So what happens here is, like, what databases thought to solve this issue is, there are two kinds of replications, like synchronous and asynchronous. Or there can be other issues also, like leader has updated the data and it has not sent right data to the follower, and leader crashed. Now whatever update I have sent, it won't be present on any mission, and I can't see my place updated to Canada. Like, there are so many issues you can see in these kind of distributed databases. First thing is, what if there is a lag of data going to the replica? And one more thing is, what if the leader crashes? My data would be lost. So there are two, as I was saying, there are two kinds of replication: synchronous and asynchronous replications. Okay. So what synchronous replication says is, let's say you have a leader replica and you have follower replicas. Now when you write a request, it goes to leader, you update it. Leader, what leader does is, it will not reply to the user immediately that I have updated. What leader does is, it will send data to the follower. Okay, let me do this. Like, it will send data to the follower, Once follower updates the data, it will gives back the acknowledgement that I have updated. Like the same here, it will send the data and it gets the acknowledgement back. So once it gets acknowledgement from all followers, then only leader will say that, okay, leader will say that I have updated the data. So if I handle case like this, write request like this, so the first issue what I was saying is, if the leader crashes, if the leader crashes, what happens? User will assume that user's data is saved, but actually leader crashed and it not sent to follower replica. My write request is gone. Okay, if leader crashes. And the second issue is the follower lag. Like if the replication is taking time to go to the follower, then in meanwhile, if the user requests data from the follower, it won't see the updated data. These are the two issues, right? By following this synchronous replication, like leader giving the user success response only if all followers updated the data. First issue is resolved. Even if leader crashes here, user will not get the success response and user will assume that his data is not updated and he will retry. So first point is gone. And what is the second point? Second point is that what about the lag. Here you won't have any lag. You are giving the response only if all the followers are saying that we have updated. So even the second issue is gone. So using a synchronous replication, your issues are solved. But is it ideally possible, like in a real world system? No, right? Because in a working project, there could be many followers, not just 2 followers. There could be thousands of followers also. Depends on the volume of the system. Is it really good that a leader waits for all 1,000 replicas to update their system and give back the result? Then your write request might take 5 minutes time. Okay, then you will give the, like whenever user comes and updates, you will give the response after 5 minutes. Is it an ideal way to do that? No, right? So what happens is, in this case, we can go for semi-synchronous replication. So what the semi-synchronous replication does is, you have to solve these two problems, okay, 1-2 problems. So we can, compromise. We cannot just go with just a single leader. Like as soon as leader updates the data, if you give the response back, then your 1-2 points will definitely, issues won't be solved. But if you take if you think to wait till all followers updates, then you will end up in higher response time. So what you can do is, you can use a semi-synchronous replication, that instead of waiting for all followers to respond back, let's keep only a single follower to respond back. So what does it mean is, now when a user when a leader gets a write request, it will send data to both followers. Okay, it will send to it, but as soon as it receives acknowledgement from this follower, then it will give the response back to the user that I have updated your data. Now it's this follower's wish, like how much time it will take. It's, if it's this follower's wish, it won't wait for this follower's acknowledgement. So this way, what happens is, whatever the write request that user has done, it is present on both two machines. One is on leader, one and other is on follower. Even if the leader goes down or crashes, you have the right data on another follower. So this way your first issue is solved, where if the leader crashes and what about my right data. And coming to the second issue, where like if the user requests data, like if there is a lag and user requests the data, meanwhile he will see the obsolete data. So that is, some, like to some extent it is avoided, because in real world applications, if you see, immediately, like replication from leader to followers, it happens, almost at a glimpse. You can't within the glimpse you will see the update going to the followers. You can't, like it takes even less than a second, so you don't observe much variation there. But there are few other tricks that we can do to handle that issue as well, which we will discuss in the later chapters. So as I was explaining the asynchronous and synchronous replication, right? So here this is a leader and you have two followers. Now, when user send a updated request, like send a write request, leader one has made the data change. Here if you see, leader one has updated it. Okay, what it is doing is it has updated the data, but it is waiting for followers. Okay, as soon as leader has updated, it has sent data to follower one and it has sent data to follower two. You can see two arrows, right? As soon as follower has sent okay, leader has sent okay to the user. If you see here, the second follower has done data change after a success response from the leader. It had happened later. If you see here, the data change on leader had happened, but it has triggered request to follower 1 and 2, but it did not send acknowledgement immediately to the user. It waited for follower 1 to send a success response, post which it has sent the data, which I was discussing in the semi-synchronous replications. Okay. So it depends on databases configuration options, which replication to use. Okay. Now, yeah, what happens is you have a leader, right? Whatever the topic I'm discussing now, it's a single leader replication algorithm. A single leader where you have a single leader and you have multiple followers. There is a multi-leader and leaderless replications also that we will talk later. And how to set up a new followers. Because as I was explaining, initially you would have had only 3 missions. Now you saw the read volume, or the system is scaling to a higher load which you did not expect. Now it's time to increase missions. Now you have increased multiple missions. Then if you just spin up a VM, or if you just spin up a database, is it sufficient? No, right? It's not that you just spin up a database. You have to have the data same as these leaders and followers on the new follower as well. Then only you can say that your follower, a new follower is added. Okay, you can't just spin up a VM without data. You have to copy the data onto this. How this copying takes place? Now you might wonder that I'll take the, like, let's say initially 1 to 10 records are there, I'll take the data set and copy. But is it really is it really applicable in the real world applications? No, because in real world what happens is data keeps changing, right? So when data keeps changing, whenever you think that there are 10 records, by the time you copy these 10 records, data set count would have got increased to 15. Then you might think that I'll copy 15 records. By the time you copy 15 records, your data would have got increased to 20. So since data keeps evolving, what you have to do to copy the data, either you have to, there are two options. Either you lock your database or bring your database down. If you bring your database down, then your high availability is compromised. You're bringing your system down and no user can access your system, and you have already promised your user that my system would be available 24/7. That is not happening. And even if you put lock on database also, that also will fail your write request. So that is not an ideal solution. So how can you set up a new follower? So how can you do that is, you can take a snapshot of the database without bringing down the database. There are multiple options to take a snapshot of the database. Okay. There are some third-party tools as well, like backup index, something like that, which will help you to take the snapshot of the database. Like you can, without bringing the database down, you take, you have 1 to 10 records, right? You take snapshot of 10 records and you copy those 10 records onto this machine. Okay. Now, meanwhile, it would have got increased to 15. Now, what this follower has to do is, in like while replicating the data to the followers, there is a concept called sequence number or bin log coordinates, depend on the database terminology. Like it's different for different databases. For Oracle it's a different, for Postgres it's a different. Oh, whenever leader write request, write request goes to the leader, right? So it will send data to the follower, then only follower will update it during replication. So while sending, it will assign some numbers, sequence numbers. So that is how even the leader also will know which what is the next sequence number I have to send, and even the follower also will understand what is the next sequence number I have to copy. So there is this sequence number logic that would be present behind it. So when the snapshot was taken, there were only 10 records, right? Now the follower, what it does is, let's say the sequence number, you can take this 10 as sequence number. Now what it will do is, it will ask leader, okay, like I have 10 sequence numbers, you give me data from 11th sequence number. Okay. Now the follower will request leader that from 11th sequence number, you send me the replication log or you send me the data. Like it is same as normal follower, right? Even if you have a followers which is not a new follower, whenever write request happen, it will send the data with the help of sequence number. Here also it's doing the same. It is just asking the leader the data. So it will ask the data from 11 sequence number, leader will send you the data. Now it will copy from 11 to 15 as well. So the same logic gets applied to the another new follower as well. Take the snapshot of the database, update your database, and from the sequence number, whatever you see in your database, from that you request a leader the new data. So whenever you are done doing that, you are caught up. Like follower is caught up and it is ready to serve the traffic, right? So this is how you can set up a new follower in a replicated databases. Okay. Now the thing now, yeah, let me go to the PPT. So here the setting up new followers, it's just like take a snapshot and copy the snapshot, and follower connects to the leader and requests the data since the snapshot was taken. I was explaining you, right, that sequence number, different databases uses different terminology. So Postgres uses log sequence number and MySQL uses bin log coordinates. So this is how the follower will caught up. Now you might get some doubt. Like you have a leader, you have a follower. When you want to add a new follower, you explain me how to do that. But if you want to, like if there are machines already working, like if one of the machine goes down, what is the loss that occur to my system? So there are two things here. Since you have leaders and followers, either leader can go down or follower can go down. Follower, like if you see the follower failure, you can call it as a catch-up recovery, and the leader failure you call as a failover. So if the follower goes down, then there is no like a potential loss that happens to your system. Because let's say your follower is down, you still have other followers to serve the traffic. So you are good with that. Like when the follower which went down comes up, what it has to do is, it has to request the data from the sequence number that it has updated last time. It has to ask the leader, give me give me the data from the sequence number. Then leader will give you the data, and once you are up to date, you can say that this follower is also up to date, it can serve the traffic. So follower recovery or follower outage is simple. You don't see any harm here. But if leader goes down, then who will accept the write request? If the leader goes down, who will accept the write request? There are, like on the process, like if the leader goes down, we call that as a failover. Okay. So like you have to recover from that if the leader goes down. So two issues we see when the leader goes down is, one is who will accept the new request, like who you have to choose a new leader. And one more thing is, let's say I choose this one as a new leader, and till now, till my leader went down, all these followers were requesting data from this leader. So all these followers has to be aware that the leader which went down is not leader anymore, and there is a new leader that has come up. I have to talk to this leader and get the data. So you have to get a new leader, choose a new leader basically, and then you have to get data from the new leader. So how can you identify the leader is down? That is the main question, right? Before even taking the steps, how can you say that the leader is down? There are few automatic methods also where you can say the leader is down, or even like if the leader is down, doing this failover, there are automatic steps as well, and there are manually also you can do this failover. I'll explain that. So determining how the leader has failed is a simple logic. There is this heartbeat kind of thing. Okay, when these followers or the other, like everyone connects to the leader, if the leader doesn't respond you within 5 seconds or so, then you might say that the leader has gone down. Like you keep you like if you keep messaging your leader, right? It need not be 5 seconds. It can be a configurable value. Like you can say that your leader has not responded within a minute. Like you have been requesting the data since a minute and your leader did not respond. Then you can say that, okay, leader went down. So there is a criteria like that in which you can choose the leader is down. Okay, now the leader is down. How can you now the thing is, how can you bring the new leader? So what I follows, or anyone, like if I'm doing a manual failover, what I have to decide is all these followers has to agree upon a common value. Okay, so there can be internally, there can be election algorithms kind of thing where each one elects a new leader. Okay, now like this one is called a consensus, which we will discuss later. So, but the most important or the ideal way to elect a new leader is whichever the follower has the recent data, then that can be elected as a new leader. Because here, let's say there are 20 records and each follower will be talking to leader to get the data, right? Now this one will have 19 records, this one will have 18 records, this one will have 17, and this one will have 20. So I should choose the one which has 20 records. So whichever has the like most recent data, that can be elected as a new leader. Okay, once the new leader elected, everyone has to talk to the new leader and fetch the data. Now this leader has gone down, right? What if this leader comes up? Now this leader should be notified that you are not leader anymore. There is a new leader, and it should fetch the data from this leader. Whatever the, like after it went down, there could be some write request that comes to this new leader, right? It could fetch that data and it should act as a follower. This is the failure process. First thing is identify whether the leader has failed or not, and the second thing is you have to elect a new leader, and the third thing is you configure the system to reuse the new leader. Okay, this is what if you do a manual failure, you should consider these things. There can be, like in databases, I guess there are automatic options also for a failover, but these are all the manual steps. Now there are lot many issues also we will see. One thing is, if you would have used asynchronous replication, then you will not have data. Like leader crashed down, you will if you use the asynchronous replication, you will not have the data, right? Now what happens? This leader has accepted few rights. Let's say some 5 rights it has accepted. It did not have like it went down, and these followers will not have the data. Okay. Now another the new leader keeps accepting the right request, and it is fine. Now this leader had come up. It has already 5 requests that were stored. Then there will be some conflicts in this case. Why the conflict will come is, let's say here I'm using a auto sequence, auto increment, like in the database you have this primary key thing, right? In especially if you are aware of the relational databases, you will have this primary key, and that is an auto increment value. This leader, before going down, it uses that auto increment, and it had stored 5. Now since this new leader is not aware, the auto increment, it started from 11, let's suppose, but it had already values from 11 to 15 with some data. Now this, since it is not aware of this 11 to 15 records, this auto increment value, it started from 11 to 15 again. Now what happens when this new leader request data of, like when the leader that went down request data from the new leader, what it will do? It will have this 11 to 15 records. It might override the data also, or it might result in conflicts because you have the same keys. So I like what you can do is either you can discard your own like discard the rights, because this is the new leader, it is accepting it. So like this 11 to 15 which is there on the leader that went down, you can discard it. But if you discard it, it's a very bad experience for the user. You said that you said that your customer that your data is there, it is stored, and now you are saying that your data is lost. So it's a durability, you don't have the proper durability. That is one loss that can happen if the leader goes down. And one more thing that comes here is there was some GitHub incident. Okay, like if you see in the distributed database, whenever it updates the data in the database, it updates cache as well. Okay, 11 to 15, something like cache. So when this leader, before going down, it updated the database 11 to 15, and then it updated the cache also. Now when the leader went, so it went down. Now what happens is the new leader had come. Okay, this new leader had come and it started updating the data, like it started writing it from 11 to 15, and there is data already in the cache. Okay, the cache data is different and the data in the database is different, because this cache data was updated by the leader that went down, and this is getting updated by the new leader, and both data are different. Now let's say like 11th user or 12th user comes and does some read query. Whenever you do the read query, first it will fetch from the cache, right, instead of the database. Then it will get some other user's data. Then it is like you are not promising privacy to your users. In 11 to 15, when the old leader inserted records, it has inserted in the cache also. Now this new leader has come and it has inserted 11 to 15, but since it's already there in the cache, it did not touch the cache. Now when the 12th user requested the data, it went to the cache and it fetched it, but the cache data is of some other user. You are exposing your user's data to some other user, which is of a big privacy concern. So you get these kind of issues when your leader goes down. Okay, and there are other cases also, like your leader came back, like your leader went down and it comes back, but it will ideal situation is it is no more a leader. It should be aware that it is no more a leader. But if it assumes that it is a leader, you will have two leaders. This is called a split brain case. Split brain is like where two nodes assumes themselves as a leader. Okay, that is called a split brain case. So here also you might result in conflicts. Okay, so that's why there are these kind of, so in this situation, what people have, what we have, database administrator or the developer should do is, whenever a new leader comes up, you should make sure that like you should somehow make sure that that shouldn't act as a leader. So we have seen three main issues, right? One is if you use a asynchronous replication, your rights would be discarded. Like you will have rights only on the leader, and if this comes up, then you have to discard the rights. And even if you discard the rights, if along with the database, if you're using cache, then you might end up in the privacy concern as well. That is one issue we see, and we can see the split brain scenario as well. Okay, so these are the problems we will see in case of a leader failure. But we will discuss, there are few solutions to this, we will discuss that. And one more thing is, as I said, you have to determine the leader that is failed, right? So initially, let's say you have put 30 seconds, but there is some network glitch, or your database is nearing maximum capacity, or it is running on a higher read volume. So in that case also, your leader could be extremely slow and it is not responding you, or your followers are requesting the data and it is not responding. Then people assume that, okay, my leader had went down, and it starts the process of electing a new leader and then consuming the data from that leader. Now your system is already slow because of the volume or the capacity or network glitch. Now you are even slowing down your system by thinking that your leader has went down. So these are the problems that will come up, like thinking that your leader went down, or how the way you handle the discarded rights. Yeah, these are the problems. There are solutions to few things we will discuss in the later videos. Thank you.